Let's solve Unit 6 Software Engineering questions. Which one of the following is the correct estimation model based on software equation? We have two terms here, estimation model and software equation. What are they actually? An estimation model for computer software uses empirically derived formulas to predict effort as a function of LOC or FP. LOC is lines of code and FP is function points. The software equation is a dynamic multivariable model that assumes a specific distribution of effort over the life of a software development project. This equation is nothing but the effort towards some software development project. So they have given this in the form of equation. The right equation will be E is equal to LOC into B power 0.333 divided by P the whole power 3 into 1 divided by T power 4. This equation is perfectly matching in option 2. Option number 2 will be the right answer. Now let's see what are the variables used in the equation. E is equal to effort in person months or person years. This T is the project duration in months or years. The capital B is special skills factor and the capital P is productivity parameter that reflects overall process maturity and management practices, the extent to which good software engineering practices are used, the level of programming languages used, the state of the software environment, the skills and experience of the software team, the complexity of the application. So just have an idea about all the variables that are used in the equation. It might be useful for you in some other question paper. Next question. Collaborative document inspection technique is used for. So just based on the question, we can say that it does not belong to integration testing and black box testing. So these are testing the software product, but here it is document inspection technique. So how does this inspection technique occur? By means of collaboration. So you can take the individual meaning of these particular terms and then get an idea. We have to check whether it is requirement validation process or requirement verification process. Collaborative document inspection is a systematic and structured process where multiple stakeholders work together to review and assess the quality of a document. Requirement validation ensures that the documented requirements reflect the actual needs and expectations of the stakeholders. Requirement verification ensures that the requirements document complies with predefined standards, guidelines and criteria. These are actually predefined standards and criteria. For this particular verification, you don't need a collaboration and all. You can just check whether they are agreeing to the norms or not. But with respect to validation, you have to check whether it is reflecting the actual needs and expectations of the stakeholders. So when you take stakeholders into consideration, here collaboration is possible. We can conclude collaborative document inspection technique is used in requirement validation process. Option number 1 will be the right answer. We can even rule out option 2. Understand why we are ruling out option 2. It is because you have a set of standards and you have a set of criteria. You don't need to collaborate with someone. You can just check the criteria and say whether it is complying or not. That is not a collaborative process is what I am trying to tell you. But here in validation process, they say multiple stakeholders work together, which is actually matching with this particular statement here, reflecting the actual needs and expectations of the stakeholders. Stakeholders in the sense people who are involved in the projects. You can take it in a broader aspect. Collaborative document inspection is a crucial technique used to ensure that the documented requirements accurately reflect the needs and expectations of the stakeholders. What about integration testing and black box testing? The integration testing focuses on verifying the interaction between integrated components or systems. The emphasis here is on dynamic testing rather than document inspection. So this does not involve inspection is what I told you earlier. What about black box testing? It's a technique where the tester evaluates the functionality of the system without looking at the internal code structure. When you work with the code, that is white box testing. When you work with the behavior of the system, that is black box testing. While test cases and scripts can be reviewed, this process does not typically involve collaborative document inspection. Next question, which one of the following is not the part of requirement management? From this we can understand that 3 of the options are a part of requirement management. Now let's see about every option. Features traceability table. This table is a part of requirement management as it helps in tracking the relationship between features and the corresponding requirements. It ensures that all features are covered by the requirements and helps in managing changes to requirements. So whenever you take a particular software, features are important. So option 1 is definitely a part of requirement management. What about the next table? Dependency traceability table. It is used to track dependencies between different requirements, which helps in understanding the impact of changes to one requirement on others. If we modify or if we introduce some change in one requirement, how far it is going to affect other is what we say as dependency factor. So definitely dependency traceability is also a part of requirement management. Next one is interface traceability table. It tracks the interfaces between different system components and their corresponding requirements. This ensures that all interfaces are properly defined and managed. Take 2 modules. If you want to communicate with the module, you will definitely need an interface. We can keep it as simple as possible. So definitely option 3 is also a part of requirement management. What is left out here? Option 4. From this we can mark option number 4, page traceability table as the right answer, but that is the only option that is not the part of requirement management. A page traceability table is not a standard practice in requirement management, as the page traceability concept is not directly related to tracking requirements. Next question. Software testability is simply how easily a software program can be tested. Which one of the characteristics does not lead to testable software? Let's see the options one by one. Observability refers to how easily you can monitor and measure the internal states of a software system through its outputs. High observability helps in identifying issues during testing, making it easier to understand the system's behavior. Just based on the outputs observation, you are able to monitor and measure the internal states of a software system. So definitely this characteristic is present. What about controllability? It is the degree to which a tester can control the state of the software under test. High controllability allows testers to set up conditions, inputs and configurations to effectively test different scenarios. You are actually controlling what kinds of conditions can be in the form of test cases, what inputs to give, what kinds of configurations you can make. So this is controllability and definitely it is a characteristic of testable software. What about understandability? It is how easily the software's behavior and logic can be comprehended. Comprehended in the sense it can be understood. High understandability allows testers to better grasp what the software is supposed to do, making it easier to design and execute tests. So definitely understandability is also a characteristic of testable software. Just looking at the terms observation, control and understandability, you can understand that only when you are able to observe what's happening in the system, you will know what is the software system doing. You are giving inputs, you are configuring the software system, so controllability is also there. Regarding understandability, only when you understand what task is going on, you can understand what kind of test you can give to the software. Repairability is about what you are going to do with the fault part. Repairability or maintainability refers to how easily a system can be fixed or updated after identifying defects. Only when you find there is a defect, there comes the term repairability. And when you take maintainability, after delivering the software to the client, you need to maintain the project, whether you need some updates, upgrades, or whether it has introduced some new errors. Everything comes under maintainability. While important for software maintenance and evolution, it is more concerned with fixing and maintaining the software rather than testing it. When will you actually go for software testing? Before delivering the product. So if you take development process, testing occurs after implementing the particular software product. After you deliver to the client, whatever happens here comes under maintenance. So only during maintenance you will be able to repair something. So we are going with option number 3, repairability, as the right answer. Next question. Find the correct sequence of prototype software development model. So let's see the prototype development model. We are starting with communication. From there we are moving to quick plan, then to modeling, quick design, then construction of prototype, deployment, delivery and feedback. Again it's a iterative process is what they have given here. So let's start from A. Since we have given the term start, every option is starting with A. What is the first phase here? It is quick plan, and here it is given as quick play. So let's take this to be quick plan. This is E. What about quick design? It is D. What is construction of prototype? It is developing prototype, which is B. What about deployment, delivery and feedback? It is delivered to customer, which is C. So we can take the starting point to be A. It starts from here. AEDBC is available in option number 2. Option number 2 will be the right answer. Next question. As per the Software Engineering Institute, the correct sequence is. This question has been repeated in previous year question papers. The Software Engineering Institute has developed a comprehensive model predicated on a set of software engineering capabilities that should be present as organizations reach different levels of process maturity. What are the different levels? We will actually term it as CMM levels, capability maturity model. That model has these 5 levels. Level 1 is initial, which is option A. Level 2 is repeatable, it is option B. Level 3 is defined, it is option E. Level 4 is managed, that is option C. Level 5 is optimizing, that is option D. A, B, E, C, D. Option number 2 will be the right answer. What is level 1? It is initial. Few processes are defined and success depends on individual effort. Level 2 is repeatable. Basic project management processes are established to track cost, schedule and functionality. What about defined? The software process for both management and engineering activities is documented, standardized and integrated into an organization-wide software process. This level includes all characteristics defined for level 2. So level 3 will include level 2 characteristics also. What about level 4 managed? Detailed measures of the software process and product quality are collected. Both the software process and products are quantitatively understood and controlled using detailed measures. Based on quantitatively understood term, what you can understand is you have some kinds of measurements and metrics that will give you some values. This level includes all characteristics defined for level 3. What about level 5 optimizing? Continuous process improvement is enabled by quantitative feedback from the process and from testing innovative ideas and technologies. This level includes all characteristics defined for the previous level, that is level 4. So this question has already been explained in those videos. So I am just telling you what are the explanation for these levels alone. Next question. Identify the correct statements from the following regarding spiral model. Now let's check about the spiral model. The spiral model is a risk-driven software development process model that combines iterative development, that is prototyping, with the systematic aspects of waterfall model. So it is combining the prototype model and the waterfall model is what we can understand in a nutshell. What is prototyping? The iterative development. Here you can see it is repeating again and again, that is iteration. You have three aspects in planning: estimation, scheduling and risk analysis. From this you can understand that this model is a risk driven software development process model. Definitely B is a correct statement. Any option that does not involve B can be ruled out. The spiral model is inherently cyclic because it involves repeated iterations or spirals of planning, risk analysis, engineering and evaluation phases. These are the general phases they have given. This is with respect to the reference book diagram. The term acyclic suggests that there are no cycles, which is not accurate for the spiral model. So they say it's cyclic because it involves repeated iterations or what we call as spirals. When it is cyclic, the term acyclic is actually wrong. So C is not in the answer list. The options involving C can be ruled out. While the spiral model does aim to balance risk management and development activities by revisiting these phases iteratively, this does not make it acyclic. So they say it is definitely cyclic. The spiral model involves a set of anchor point milestones, which are critical points in the development process where key decisions are made, risks are assessed and progress is evaluated. Spiral model involves a set of anchor point milestone is perfectly right. So D is also right. We can rule out option A and we can go with B and D only as the right answer. Option 4 is the right answer. Let's check with A statement. Spiral model is an incremental process model. When you take earlier versions of certain software engineering books, they would have actually started telling that it's prototyping plus waterfall. When you take explanation kind of articles or search engine results, they will say it's an incremental process model because even in incremental process, this iterative development will take place. So let's understand one thing. As per new edition books, prototyping and spiral models are placed under evolutionary process models. So let's understand the difference between incremental model and evolutionary model. Incremental model builds the system in small, manageable increments or iterations. Each increment adds specific functionality to the system until the complete product is developed. Take for example, a product is having 5 phases or 5 pieces of modules. Every module is taken to be an increment. So you build one increment at a time and finally you are joining all the increments together to get the complete product is what they say here. So for every increment you are undergoing the same set of phases and that is what you compare here to iterations. This is incremental model. If you take evolutionary model, this is an iterative approach that focuses on evolving the system based on continuous user feedback and changing requirements. Once you finish one set of iteration, you automatically get feedback and make changing requirements to it. So this process is happening in this pattern. Under evolutionary model only you have prototyping model, and taking prototyping along with waterfall aspects, you are getting spiral model here. So spiral model is a part of evolutionary model and not incremental model. But when you take AI generated answers or if you go for search engine answers, they may have a word like it is also an incremental model. But this incremental model is having similar features with evolutionary model in terms of iterations. They also form a cycle. But how the cycle is formed in these two models have a difference. Incremental model work like module based. Say for example, that's what I told as an example that there are 5 increments for this particular product. Every increment undergoes the same set of phases and finally you get the complete product. But here you don't have increment approach. Here you are evolving the system continuously by changing requirements. On the whole you are developing in evolutionary model, but increment by increment you are adding specific functionality to the system in incremental model. There is a difference between both the models, though they share many characteristics in common. So that is why we are ruling out option A. Next question. In software engineering, Jackson's principle is based on. Actually, this person Jackson has written a book on software engineering. Only in that particular book or software engineering books which have referred this particular person's book will have these details. If you take normal software engineering books, you may not find this approach. So we have to choose only 3 out of these 5 options. Jackson's principle in software engineering is primarily based on structured programming, clear code and focusing on data structures and operations. Now let's see about option A. Designation refers to assigning specific roles and responsibilities within the code structure. So what is the designation talking about? Clearly designated roles make it easier to update or modify specific parts of the code without affecting other components, enhancing maintainability. It is giving a kind of role for a part of code. They can say you can update only this part without affecting the other part. This is designation. So A is included in the answer. What about the next one? We have definitions, which is B. Definitions focus on clearly defining data structures and operations. So this particular point is given. Defining data structures clearly ensures that the code is organized and that each part of the program knows what data it should handle. Having well-defined operations and structures ensures that the logic of the program is consistent and easy to understand, facilitating better design and implementation. Now the next point, refutable assertions. This is C. Refutable assertions involve making assumptions in the code that can be tested and potentially disproven. Assertions help in validating the correctness of the code by checking if certain conditions hold true during execution. In case if an assertion fails, this will indicate a potential bug or issue. Using refutable assertions make it easier to identify and debug problems in the code. By testing assumptions, developers can quickly pinpoint where things might be going wrong. So if you are able to test and disprove something, that is refutable assertions. You are actually working with the code here. So clear code aspect can be taken. At the same time, when you use designation, designated roles especially, that comes under structured programming, you can equate those terms. So we can include B and C also in the answer. Option number 1, A, B and C only will be the right answer. What about formal review and requirement elicitation? Requirement elicitation is you are getting the requirements from the stakeholders by means of interviews or questionnaires. You are eliciting, you are asking for the requirements or you are collecting for the requirements. So requirement collection is not related to Jackson's principle. So we are ruling out this. What about formal review? Review happens on already present things. So review is also not a part of principle. So take the clue as structured programming, clear code and focus on data structures and operations. Just keeping these 3 terms as hints, we are going with A, B and C. If you take Jackson's book, you will have detailed definition on all these 3 options. Designation, definitions and refutable assertions. Next question, match list 1 with list 2. List 1 has software risk and list 2 has its uses. Let's see one by one. What about predictable risks? Predictable risks are those that are anticipated based on previous experiences or known factors. If you take a particular project and you have gained some experience and you know what kinds of errors are possible, when you are going to start a second project, you will automatically predict certain risks based on the previous experiences what they say. A will be mapping to 4. A4 is available in 2 of the options. We can rule out the other 2. What about business risks? Business risks are associated with the potential impact of the project on the business itself. That includes financial, market and operational aspects. Strategic risks involve high-level decision making and planning that can affect the overall direction and success of the project. Actually, this risk is associated with business level is what they say. We can address business related risks through high-level decision making and planning. What does high-level decision making and planning say? It says they are strategic risk. So, B will be mapping to 1. B1 is available in option 4, so we can even rule out option 1. What about project risks? Project risks are specific to the execution and management of the project, including timelines, budgets, and deliverables. This should ensure effective staffing and coordination to manage project execution risks. So, we are involving staffing and coordination, which is equating to staffing and organization in list 2. So, C will be mapping to 2. C2 is available here. What about past project? Past project risks refer to the challenges and issues encountered in previous projects. These risks provide valuable insights that can inform the implementation process. By considering past project risk, teams can avoid repeating mistakes, leverage successful strategies, and improve the overall implementation of the current project. So you can take it like past project will help you in implementing your new one. So D will be mapping to 3. D3 is available here. A4, B1, C2, D3. Option number 4 will be the right answer. With this we are completing Unit 6 solutions.